Deploying your LaTeX service on AWS, a step-by-step guide using Jenkins and CDK. This podcast is brought to you by Business Compass LLC. We are an Amazon Web Services advanced consulting partner. We build and migrate workloads to Amazon Cloud. Our website is businesscompassllc.com. Our phone number is 973-638-2228. Our email address is contact@businesscompassllc.us. Introduction: Preparing for cloud deployment. In today's fast-paced development environment, deploying code seamlessly and efficiently is crucial. This podcast walks you through taking a LaTeX service from a local setup to a live cloud environment using Python, Flask, Docker, Jenkins, and AWS CDK. By the end of this journey, you'll have your LaTeX service up and running on AWS, fully automated with a C/CD pipeline. Step 1. Crafting your LaTeX service with Python and Flask. The first step is to build a simple LaTeX rendering service using Python and Flask. Flask is a lightweight web framework that allows you to quickly and easily create web applications. Set up your Flask environment. Install Flask via pip and create a basic Flask application. Pip install Flask. Create the service. Write a Python script that accepts LaTeX input, processes it, and returns the rendered PDF. From Flask import Flask, request, send_file. Import subprocess. App equals Flask _name _. At app.root/render, methods equals postdef_render_latex. Latex_code equals request.form latex, with open input.text, w, as f. F.write latex_code, subprocess.run ptflatex, input.text, return send_file input.pdf, as _attachment equals true. If _name _ ==main _. App.runHost equals 0.0.0.0, port equals 5000. Test locally. Run your Flask application locally and test it by sending LaTeX code to the /render endpoint. Step 2. Containerizing your application with Docker. To ensure your application can run consistently across different environments, you'll containerize it using Docker. Create a Docker file. This file contains instructions on how to build the Docker image for your LaTeX service. From Python 3.8 Slim. Run apt-get update and apt-get install y. TextLive LaTeX base. TextLive fonts recommended. TextLive fonts extra. TextLive LaTeX extra. Workdir/app. Copy /app. Run pip install Flask. Expose 5000. CMD. Python, app.py. Build and run the Docker image. Use Docker commands to build and run the image. Docker build t LaTeX service. Docker run p5000 to 5000 LaTeX service. Verify the container. Access the service at http://localhost:5000/render to ensure it's working as expected. Step 3. Pushing your code to GitHub. Now that your application is containerized, it's time to push the code to a version control system. Initialize a Git repository. If you haven't already, initialize a Git repository in your project directory. Git init. Commit and push. Add all files, commit your changes, and push the repository to GitHub. Git add. Git commit initial commit. Git remote add origin your GitHub repo URL greater than. Git push origin master. Step 4. Automating deployment with Jenkins. Automation is critical to a smooth deployment process. A popular C/CD tool, Jenkins, will automate your deployment pipeline. Set up Jenkins. Install Jenkins on your server or use a cloud-based Jenkins service. Configure Jenkins pipeline. Create a Jenkins pipeline script, Jenkins file, in your repository. Pipeline. Agent any. Stages. Stage build. Steps. Script. Docker.build LaTeX service stage test. Steps. Docker run LaTeX service PyTest. Stage deploy. Steps. With AWS credentials. AWS credentials. AWS ECR get login password region US East 1. Docker login username AWS password state in your AWS account ID dkr.ecr.useast1.amazons.com. Docker tag LaTeX service latest your AWS account ID dkr.ecr.useast1.amazonos.com/LaTeX service latest. Docker push your AWS account ID dkr.ecr.useast1.amazonos.com/LaTeX service latest. Trigger automated builds. Set up webhooks in GitHub to trigger Jenkins builds on each commit. Step 5. Creating cloud infrastructure with AWS CDK. With your code in a Docker image, You must create the cloud infrastructure to host it. AWS CDK, Cloud Development Kit, allows you to define your cloud infrastructure using code. Install AWS CDK. Ensure that you have AWS CDK installed. npm install GAWS CDK. Define infrastructure. Create a CDK stack that defines your infrastructure, including an ECS cluster, a Fargate service, and a load balancer. Import as CDK from at AWS CDK/core. Import as ECS from at AWS CDK/AWS ECS. Import as EC2 from at AWS CDK/AWS EC2. Import as ECS_patterns from at AWS CDK/AWS ECS patterns. Export class LaTeX service stack extends CDK.stack. Constructor scope, CDK.construct, ID, string, props, CDK.stack props. Superscope, id, props. Const VPC equals new ec2.vpc this, VPC. Max ESI, 2. Semicolon. Const cluster equals new ECS.cluster this, cluster. VPC, VPC. Semicolon. Const Fargate service equals new ECS_patterns.application load balanced Fargate service this, Fargate service. Cluster, cluster. Task image options. Image, ECS. Container image. From registry your AWS account ID dkr.ecr.useast1.amazonoz.com/latex service latest. Container port, 5000. Semicolon. Deploy infrastructure. Use the CDK CLI to deploy the infrastructure. CDK deploy. Step 6. Deploying your code and going live. With your infrastructure in place, the final step is to deploy your LaTeX service and make it live. Update Jenkins pipeline. Ensure that your Jenkins pipeline pushes the Docker image to ECR and deploys it using AWS CDK. Access your service. Once the deployment is complete, access your service using the DNS name provided by the load balancer. Monitor and scale. Use AWS CloudWatch and ECS to monitor your service and scale as needed. Conclusion: your LaTeX service on the cloud. Congratulations! You successfully deployed your LaTeX rendering service to AWS using Jenkins and CDK. This podcast provides a comprehensive overview, from local development to cloud deployment, ensuring your application is live, scalable, and maintainable. Thank you for listening to our podcast. Please share this podcast, visit our website and follow our social media links.